Okay, now let's say we're trying to add fractions together. You cannot add fractions together unless the denominators match. So here the 7 and the 7 match. So I can just add the numerators together. I'm going to write this extra step, but you don't have to. So I'm really just adding the numerators 3 plus 2, and they're all going to go over the original denominator of 7. Don't add the denominators together. Don't say 7 plus 7 is 14. That would be incorrect. Don't do that. So we're going to say 3 plus 2 is 5. We'll end up with 5, 7. Over here we say 2 tenths plus 3 tenths. Again, since the denominators match, we can just add the numerators of 2 plus 3, put that over 10. That would give me 5 over 10. Now, we have to simplify to get the correct answer. 5 over 7 was already simplified, but 5 over 10 is not simplified because I can divide both 5 and 10 by 5. So we would divide both those by 5, and that would give me a 1 over 2. And since now I can only divide 1 into a 1 and a 2, this is simplified. That's your final answer. Same thing over here. The only thing I can divide evenly into both a 5 and a 7 is a 1, so it is simplified. Now, there's something called the least common denominator. It's also referred to as the least common multiple. It's a more generalized kind of concept. And it really is what it says, which is it's the least common or the same multiple of the numbers. So let me do a really quick simplified example of this. So let's say we're doing the least common multiple of a 2 and a 3. Okay, so let's say 2, 4, 6, 8, right? So I'm just adding 2 each time. 2 plus 2 is 4, plus 2 is 6, plus 2 is 8. And then we say 3, 6, 9, 12. Same thing here. 3 plus 3 is 6, plus 3 is 9, plus 3 is 12. Now, when I say least common or least the same multiple, it's exactly what it sounds like. Which of these numbers matches first? And in this case, it's the 6. So the least common multiple of a 2 and a 3 is a 6 because the smallest number that's a multiple of a 2 and a 3 that matches is the 6. So it's the least common multiple. Okay. Now the problem with this is once the numbers get fairly large, or if you add in a third number, a fourth number to find the least common multiple, this gets really out of hand really quickly. Okay, so we need a kind of a shortcut to this. So one shortcut we could do is, I'm going to show you on the first problem over here is, you could take the larger number, 24, and try to divide the smaller number into it. Now if that doesn't work, 24 plus 24 is 48, you try it again. And if that doesn't work, 48 plus 24 is 72, you try it again. 72 plus 24 is 96. You try it again. And then finally, 96 plus 24 is 120 divided by 15. And that one actually works, right? So you get your 8. Okay, so that means the 120 is the least common multiple of both of these 120. That's kind of method. So this is method 1. It's method 1. Over here, we call this method 2. And they're just the same concept done 2 different ways, right? Now you can see where even the method 2, which is a little more compact, it's still not very compact. So we need a little more advanced method. So another way you can do it is, we can do the prime factorization and pick each element to the highest power, which I'm going to show you over here. So let's say we want to find the least common denominator of an 8x and a 10x. All right, so we could say 8 is 2 times 2 times 2, which is 2 to the third. And 10 is 2 to the first times 5 to the first. Now they both also have x's, so you can put the little x on there if you want. And the x is to the first power. So to find the least common multiple, or in the case since it's in the denominator, you're going to say the least common denominator, you would simply pick each element to the highest power. So there's a 2 to the first power, and there's a 2 to the third power. So we know that the least common denominator is going to have a 2 to the third power because 3 is larger than 1. That's it. Now, we do have a 5 to the first power at the bottom, but we don't even have a 5 on the top. Well, 5 to the first power is bigger than 5 that doesn't even exist, basically, right? So we're just going to put 5 to the first power. There we go. Then we have an x to the first power on top and an x to the first power on the bottom, so it's x to the first. Okay, very good. So what we end up with is 8 times 5 times x, or 40x. So 40x is the least common denominator of 8x and 10x. So let's try it over here. Same kind of concept, right? So the prime factorization of 6 is 2 times 3, and then this one actually has an r to the second power. Prime factorization of 4, should probably put the rest in there, right? R squared, r to the third, is going to be 2 times 2 times r to the third power, or 2 squared times r to the third power. So if we're looking for least common denominator, we're going to include each element to the highest power. So we have a 2 to the first power on top, and we have a 2 to the second power on the bottom. So we actually have to include the 2 to the second power. We have a 3 to the first power on top, and we don't even have a 3 on the bottom, so we have to include the 3 to the first power. We have an r to the second power on top, and we have an r to the third power on the bottom over here, right? So we have to include r to the third power. And what that gives you is a 4 times 3 times r to the third power, which gives me a 12 r to the third power. And so it looks like the least common denominator in this case is of a 6r squared and a 4r to the third power is a 12r to the third power. Look at that. Now, you can't add and subtract fractions unless they have the same denominator. So if they don't have the same denominator, in this case you have a 15 and a 9, they do not have the same denominator, is your first step is you have to make them have the same denominator. So we're going to find the least common denominator of 15 and a 9, and then we're going to make them both have that denominator. So first question in this one is, what's the least common denominator of a 15 and a 9? And we have multiple ways of doing this, right? I could count out by 15s and then see which one matches. I could try to divide 9 into 15 repeatedly until that works. So I'll do method number 2 first, just for fun. We'll see what happens, right? So it'd be something like 15, 30, 45, and can't divide 9 into the first one, can't divide into the second one, but I can divide into this one. Successful. Boom. So it looks like the least common denominator is a 45. So again, that's method 2. Okay, method 2. So all it means is now is we need to turn both the 15 and the 9 into 45s. We turn the 15 into a 45 by multiplying by 3. And to keep this an equivalent fraction, or not break the value of the fraction, we have to multiply the numerator by 3 as well. To turn a 9 into a 45, we multiply it by 5. We also have to multiply the numerator by 5. Again, to keep it an equivalent fraction so we don't break it. So now what we end up with is 12, 45 plus 25. 45. And now, since they are like fractions and that the denominators do match, we can simply add the numerators together. I'm writing this extra step. You don't have to. So we're just adding the 12 and the 25 together. We're just sticking it right back over 45. 12 plus 25 is 37 over 45. And you end up with a nice little fraction like that, right? Okay. Now, if you can't tell what you need to multiply the 15 and the 9 by to get the multiplier, what you would do is you take the 45, the least common denominator, and you would divide it by the original denominator, and it will spit out what you need to multiply by, right? So that's an option. If you can't do it mentally, that's fine. So another one, 45 divided by 9. If I do that, that would give me a 5. And sure enough, that's what I ended up multiplying by, right? So that's the trick. If you can't do it mentally, you can just do that trick and then find what your multiplier is going to be. Okay? Let's try the next one. The least common multiple of a 2 and a 4 is a 4, right? 2, 4, 4. All right, so we multiply that by 2, multiply that by 2, and that'll give me a 14 over 4 plus 11 over 4. And so now that the denominators match, we will keep the denominator and add together the numerator, 14 plus 11 over 4. And 14 plus 11 is a 25 over 4. I know that looks like a y, that's not bad. So 25 over 4. Same thing's true whenever you're trying to subtract, is that you can't subtract unless they have the same denominator. Right? So in this case, we do have like denominators. They both have 8. So since they match, we can just dive right in and subtract. So we're going to say 15 minus 3 over 8. 15 minus 3 is a 12 over 8. In this case, we can reduce these because we can divide both 8 and 12 by 4. And that would give me a 3 over 2. So we have 3 over 2. Boom. Okay, the next one, we have 16 and 9. So these denominators do not match. And since they do not match, we need to find the least common denominator. So we need to find the least common denominator of a 16 and a 9. Okay. We could count, right? So we could say, 16, 32, 48, 64, so on and so forth, and eventually get it. That's pretty inefficient. So what we're going to do is we're going to do the prime factorization this time, okay? So what you do is you say 2 times 2 times 2 times 2. That equals 16, or you say 2 to the 4th power. And for the 9, you could say 3 times 3 is equal to 3 squared. So in this case, the least common denominator is just going to simply be 2 to the 4th power multiplied by 3 to the 2nd power, which is going to be 16 times 9, which is going to be 144. Okay, so it's going to be 144. That means basically I'm going to have to multiply this one by 9 and multiply this one by 16. Now, some of you might notice that those are I just multiplied the denominators by each other. That will work. Very seldom is that going to give you the least common denominator, but it will give you a common denominator, in which case you're just going to have to simplify more at the end. So that is a valid strategy to adding and subtracting fractions, is simply to multiply the denominators together. But again, you're going to have to do more simplifications at the end, and you're going to have to deal with larger numbers in the meantime. So it works, but it's not necessarily the most elegant way of solving these, right? Okay, so 15 times 9 is going to be 135 over 144. That's a 4. And then minus 16 times 4, which is a 64, over 9 times 16, which is a 144. That's a little better. Now, since the denominators match at this point, they're like fractions, the denominators match, we can subtract the numerator. So we have 135 minus 64 all over 144. We keep the denominator. And 135 minus 64 is going to be 71, right? So 4 from 5 is 1, and then 13 minus 6 is 7. And then we keep that over 144. And in that case, we can't reduce it. There's nothing we can divide both into a 71 and a 144, except 1, so in that case, we're done. So let's move on to the next one. Next one, we have an 18 and a 15 as a denominator. What can we... Well, first of all, they don't match, so we have to make them match. So we're going to find the least common denominator. So how do we do that? So we can dive in and use the prime factorization. So we say 2 times 3 times 3, which is 2 times 3 to the 2nd power. Or you have 15, which is 3 times 5. And if you want to find the least common denominator, you pick each of these elements, right, numbers in this case, to the highest power. So we have a 2 to the 1st power, no 2 in the bottom, but we have to include a 2 to the 1st power. Then we have a 3 to the 2nd power on top, and we have a 3 to the 1st power on the bottom, so we're going to include a 3 to the 2nd power. Then we have a 5 to the 1st power on the bottom, but we don't have 5 in the first one, so we have to include 5 to the 1st power. And that would give me 2 times 9 times 5. 2 times 9 is 18. 18 times 5 is 90. Okay, so we need to turn these both into 90. So 18 times 5 is 90. We also have to multiply the numerator. And 15 times 6 is 90. We also have to multiply the numerator. 7 times 5 is a 35. We put that over 90. And then we say minus 4 times 6 is 24. We put that over a 90. Since now the denominators match, now we can simply subtract the numerator. So we say 35 minus 24 all over 90. 35 minus 24 is 11. 11 over 90. And there you go. Okay, the least common multiple of a 2 and a 4 is a 4. So we multiply the 2 by 2. We have to multiply the numerator by 2 as well. And now the denominators are going to match. So now we have an 18 over 4 minus 7 over 4. We have an 18 minus 7 over 4, which is the same as 11 over 4. Not too bad, right? Okay, so we are going to be adding the signed numbers. Now, if the same sign, I know you guys know it, I'm breaking it down probably too far, but basically the point I'm trying to make here is if I add two positives together, I get a bigger positive. And if I add, right, two negatives together, I get a bigger negative, right? So if you're adding two numbers with the same signs, you end up with an answer with the same sign. That's it. That's the point I'm trying to make here. And I know most of you are going to be like, yes, I know, but just want to make sure it's very clear. That's the rule for the sign. This is when it's simple, right? So positive 2 plus positive 3 is positive 5, just like a negative 2 plus a negative 4 is a negative 6. So you're adding numbers with the same signs, you end up with an answer with the same sign.